Hey everybody, my name is Stephen Feuerstein, the guy who pretty much knows PL/SQL and not much else. Here for another Feuertip. I'm here all by myself. Michelle's on holiday. She's not an American, so she takes vacation. And here I am, having to do all this work all by myself, but it's okay. All right, so welcome Rachel, glad to have you back. Hey everybody. So what I'm going to talk about parameters today, parameters of subprograms. Before I get into that, I went on a pretty big rant, I believe the last Feuertip, talking about what was going on in this country regarding reproductive rights and calling on Oracle to take action. Just to let you guys know, Oracle took action. So Oracle has extended benefits to its employees to support access to reproductive health services in the United States. Kudos to Oracle. Okay, so moving on, I'm going to talk about parameters for a bit. I've got a really interesting cultural artifact. It's a thing. It's not a book or a movie or anything like that. And of course, take your questions and comments along the way. So let's talk about parameters. And I'm not talking about database parameters like initialization parameters. I'm talking about parameters of subprograms. Subprograms are the general term for procedures and functions. We call them subprograms, I guess, because they're part of a package. They'd be subprograms in a package. Anyway, parameters for procedures and functions, though cursors can also have parameters. And it's actually possible to write programs without any parameters at all. Sometimes it makes sense to do that. Usually there's something wrong if you've written a procedure or a function and it has no parameters. So we'll talk about when you add parameters, some of the nuances of the different modes and ways to specify them and so on. Let's share my page, my screen. Let's go over to SQL Developer. Okay, so first of all, who needs parameters? So here's a procedure, do stuff with date and ID. It has no parameters. And what I've done here, just to show you how you can write some really bad code to avoid parameters, I've created a package, my globalized parameters. It's got a date, it's got a number. We could have one of every data type. We could have 10 of every data type, who knows? And therefore, to use this procedure and not have parameters, I simply set the values of my globalized variables, essentially, or globalized parameters. And then I call do stuff with date and ID. So if you say to yourself, you know, I really don't like parameters. They're a pain in the neck. I like to have my procedures and functions really clean and simple. No parameters, junking it up. This is how you could do it. Would you want to do this? You really don't want to do this. And I'm sure all of you are pretty well comfortable with the fact that this is a bad idea. Very simply and baldly, I've got a lot of globalized references, out of scope references to these variables. In fact, look, I even forgot to put that prefix on it. It would not even compile. Why would I even bother running it? So the problem with this is if I look at this procedure, it doesn't tell me anything about what it depends on. And there are many kinds of ways to have dependencies in subprograms, but the clearest one is dependencies on data points, like I need a date, I need an ID. So all this information is hidden away inside the procedure. Therefore, there's no way to know without looking inside the body of the program what I need to do to use it properly. And that's generally a bad idea. So in general, the header of your procedure or function should fully inform the user of that program what they need to pass and what they need to do to get the procedure to work right. Clearly, in a database programming environment like PL/SQL, you can also have references to tables and so on inside your procedure and function. That makes it non-deterministic. That means you have to look inside to get some sense of what's going on or have external documentation. But parameters are the clearest, simplest, most important way to externalize dependencies, make them explicit in the header of the procedure or function, make that code much easier to use. All right, so I'm just going to run through some interesting things that I found, or maybe not so interesting things, along the way for parameters. So first of all, there are 3 parameter modes, 3 ways to pass parameters. The default is in. So if I don't include the word in, this is an in parameter, which means read-only, and we'll talk a little bit more about that in a moment. You can have in-out, which means you can read it and you can also change it. So it's coming in and it's going out. And you can have out, which means you're setting a value that's being passed back. So those are the different parameter modes. And when you pass, let's talk about pass by reference, pass by value. When I pass a parameter as an in parameter, I pass it by reference. That means inside this procedure, any reference to that parameter is a direct reference to the variable being passed in, compared to out and in-out parameters, which by default pass by value. And that means that when I look at it inside my procedure or function, I'm actually looking at a local copy of that thing. PL SQL does a copy in, copy out. So I'm not directly modifying or looking at that thing itself that was passed in with an out or in out. That has some consequences around performance. We'll talk about the NOCOPY way to get around that soon. If I have an in parameter, only in parameters can have default values, just like a column can have a default value. And if I provide a default value, then I don't have to provide a argument to go with this parameter. And that's another part of the nomenclature, the terminology that we'll see as I go through these other examples. These are called the formal parameters. And when I call the procedure or function, these are called the arguments or argument values. So I have formal parameters and I have argument values that are associated with those formal parameters when I call the procedure or function. Okay, so we've got our different mode set. We've got our ins, outs, and in-outs. I'm not going to talk about naming conventions. I've changed mine over the years. My feeling is like it doesn't matter what naming convention you use. Just make sure it's consistently applied in your code and hopefully your entire team's code. But if you want to do P underscore, that's cool. If you want to do underscore in, underscore out, which is what you can see I was doing here, whatever works for you. Okay, so let's take a look at some of the nuances of these different moded parameters. So here's a procedure that takes an in parameter, a single in number, and then what I'm going to do is take a look at it and change the value of it. Okay, so first of all, let's compile. Looks like I'm going to have to connect to the database. It'll take a moment or two. Anybody have a question or comment yet? Probably not. So that's okay. There we go. So now I'm going to try to compile this procedure. And you know what? Oracle does not like that. So it says at compile time now, not at runtime. At compile time, it's noticed that I've got an in parameter and I'm trying to make a change to it. That's a no-no. So if it's a read-only parameter, you're not allowed to change it. So that would also make sense then that if it's an out parameter, you wouldn't be able to read it. Let's take a look. So here's a procedure called read out. Let's make sure it compiles and we'll take a look at it. It compiled. Cool. So I'm going to display the initial value. So when I call this procedure, I have to pass a variable for this parameter. I can't pass a literal value because I'm going to be putting a value into it. It's got to be a variable. And then I'm going to check to see what the initial value is coming in. I'm going to set a value to it. I'm going to take a look at its new value. I'm going to raise an exception, trap the exception, take a look at the value then, and then re-raise the exception. Now, you might say, looking at this code, but wait, Stephen, if it's an in parameter, you can't change it. If it's an out parameter, surely you can't look at it. Well, that's not really true. So let's run this code now. I'm going to default the value of n to 100. I'm going to pass in that 100 value, n, with 100. And then I'm going to trap the exception and see what it looks like afterwards. So I run this block of code. And I get the initial value is null. Wow, I passed it, I set it 100, I passed it in, and it says, nope, your value is null. And in fact, that's the rule for out parameters. It doesn't matter what the value was in that variable coming into the procedure or function. You're going to write over it, or not, depending on what you do with your program. But it ignores whatever the current value is once you've started running the program. So this is null. I assign a value. Cool, it's an out parameter. And I can see it immediately. So that's odd, but really helpful. I can look at the value of my out parameters inside my procedure or function. Notice that if the exception is raised here and I trap it internally, the value is still 1. So it didn't wipe it out, but because I re-raised and it came out unhandled, the value is set back to 100. So that's an example of essentially a kind of rollback that occurs when an exception has been raised in out and in out parameters if you don't use NOCOPY. And let's take a look at this last one. That's the same one. Okay. Now, the other thing I wanted to show you is that if I don't set a value, so let's change this. Let's get rid of the assignment. Let's get rid of this. Let's run this again. So I'm going to recreate my procedure. doesn't really do much of anything except display null a couple of times, and then it comes back. Then I'm going to run my procedure. Now, this is interesting. N is assigned the value of 100. I call the procedure, and I pass it in. It doesn't set anything. It doesn't do anything with N except try to look at it. But when it comes back, it's null. So that's the other key thing to remember about out parameters. If you don't assign a value to that parameter, it will come back as null, not what it was before. It doesn't come back unchanged. The unchanged state happens if the procedure or function terminates with an unhandled exception, forcing a kind of rollback of your application state, session state. But if you don't raise an exception, if it doesn't fail, it is set to null. So a couple of key things to remember about out parameters that might not be really clear just at a glance. Okay, let's do a quick glance at NOCOPY. You know I've talked about this before. Just to remind you. Look at all that uppercase. This is a good example to look at. Yes. Okay, so right here. So if I have an in-out or an out, by default, as I mentioned, there's a copy in and a copy out process that happens because we're passing by value. We're not referencing that variable directly. And there's an advantage to that. If something goes wrong and I roll back in my procedure or function, I end with an unhandled exception, then Oracle executes this kind of rollback. You might call it a soft rollback in my session. And anything that had been sent in for changing reverts back to the value that it had. That's good in some ways, but the bad side is that you do copy in and copy out. So the Oracle PL SQL team recommends, and you'll see this in warnings as well if you have compile time warnings turned on, they recommend that you always add the no copy hint to your out and in-out parameters. And what this tells the compiler, the runtime engine, to do is not make a copy. So when I've got an out or an in-out, it's passed in by reference, not by value. And as I make changes, for example, here I am removing elements, I might be changing values of individual elements. The change is made directly to the thing that was passed in. So, and then when I terminate my procedure successfully, we're done. We've made changes, no copy in, no copy out. The downside being if something goes wrong and I do raise an error, my value, the variable that I've passed in for that out or in-out, for the in-out in particular, might be partially changed. Because we were doing by reference changes to it, it was being changed in real time to my actual variable. And that doesn't roll back if something went wrong. So use no copy for all out and in-outs. Be aware that if an exception is raised, if it fails with an unhandled exception, you should not trust the values and the variables that were passed in for those parameters. All right. Let's see. Now, you can get information about your parameters in a couple of different ways in PL SQL. The classic way is to do a query against the all arguments or user arguments view. So this view will basically go into the data dictionary and find all the procedures, all the parameters that are assigned for a specific subprogram of a package or a schema level procedure or function. Let's see. So show procs. Let's just run this real quick. Hopefully we'll not have to reconnect. Yay. So here, what it's done is gone through, I've looked for program units with a long argument. So I created this procedure that lets me pass in the type that I'm looking for. Find me all the subprograms, all the database objects, coding objects that have a given type. And I simply go through all of the arguments. They should be called parameters, actually, but they're all arguments, looking for that specific type. So if you want to get some information about your environment, for example, I want to make sure that nobody's got longs as a data type, right? Nobody should have a long data type. They should be clops at this point. You can run a query and find out if anything is labeled with a long type. In addition, and probably better to use if you're on 11G or higher, which, boy, I sure hope you are, you can use PL Scope. So PL Scope is a feature baked into the compiler that if you have turned on, and this is how you turn it on, when you compile a program unit, package, procedure, or function, the Oracle compiler basically tears it apart and gets information about every single identifier, named element in your code, parameter, procedure name, package name, etc., and all the SQL statements. And then you can do all sorts of really interesting analysis. So here I'm turning on PL Scope settings, compiling this code, And then I've got a little program here that basically just looks through all the identifiers it found. So let's go ahead and run this code. Okay, this is interesting. It compiled my function, my package and package body. And since I had warnings turned on, it said, oh, by the way, you've got some unreachable code. Oh, too bad, but we're not going to look at that right now. But you should if you ever get that error in your own work. And then let's run this query against the all identifiers. Okay, so here's the output from all identifiers. So basically I said, get all the identifiers, all the rows in the all identifiers view for this database object. And notice it has type, among other things. And then I put it all into a string. So here's the type, package, procedure, and notice formal. So this package has a procedure called my procedure. My procedure has two different formal parameters. So there you see the use of that term formal. That's the type of data it is. That's how you know it's a parameter inside PL scope, because it's called a formal. And then you can get the name and the type and all of that sort of thing. So if you ever want to do any analysis in your code, regarding use of parameters, you can use PL scope, or you can use the all arguments data dictionary view. All arguments is easier to use depending on the type of query you've got. PL scope is much more in depth, much more nuanced. You'll get much more information about your applications. So one of the best things that I like about parameters is being able to use them to support backward compatibility. So in general, when I write a package and it's got 10, 20, 100 procedures and functions in it, they've got the parameter lists all set, and I publish that out and people start to use it. My perspective is that I've signed a contract with those developers. They use my code. I have to be responsible to maintain that code in a way that doesn't mess them up. One of the ways I can mess them up is I give them this package version 1.0. They build all sorts of code against my 1.0 API. And then I'm like, oh, I got a bunch of great ideas. I'm going to do a 2.0 of the API, and I'm going to get a whole bunch of parameters. And all of their code, they install the new version, and all of their code breaks. That's very rude and should be avoided if at all possible. So what you want to do is look for backward compatibility as you enhance your code. And there are a number of aspects to doing this. In terms of parameters, there are two things to think about. One is using default values. So if I want to add a new parameter to an existing procedure, let's say insert thread. This is the original code for the quiz database, PL SQL challenge, managing discussions. And suppose that I wanted to add approved by user ID. Previously, we didn't do approvals. You just submitted your discussion. It was immediately published. What a bad idea. So we want to do approvals. So what I would do is add this new parameter. It's an in parameter. Who's doing the approving? And I can say default null or default app config default admin ID, whatever it is. It could be a function call. It could be a whatever. So what I do is provide a default value. And as you might have seen with insert statements, when I'm inserting a new row into a table and I have columns that have default values, I don't have to supply an argument value for this formal, and it will automatically pick this up. So one of the best ways to ensure or honor the contract with your users, the users of your APIs, is when adding new parameters, always add them to the bottom. If they're in parameters, always add a default. Default null is usually a good fallback position, but you may have something else you want to use. And that way, all of their existing invocations will work just fine. Now, another way to approach backward compatibility that has to do with parameters, but more has to do with overloading, is let's say that the first time I start building my API, my table API, in fact, I'm building one of those right now. Let's see, let's go over here, pull this up. I'll probably have a Feuertip conversation about this in the future. I can't remember if I already have. I've had, 46, coming on 50 of these now. But discussion about table APIs and transaction APIs. I published a tweet recently about table APIs, and somebody said how yucky they were, and I would never put a procedure just around an insert. So let's talk about that for a moment in the context of this work. So I'm building some notifications, an API to support notifications. And we pass in all this different information. And this is actually, the first version of this was generated by Apex for me, which was really nice. I didn't have to write all this code. And what I'm going to do is pass in all the values for the arguments, and a lot of them have default values. And then I'm going to pass back the ID. Nice. And I can use this to create my new notifications. And I'm sure you've had this situation yourself. Sometimes I don't really want that ID. Sometimes I need it. I want to do an insert, and then I'm going to take that ID and I'm going to do more stuff with it. But sometimes I really just want to do the insert and I don't care about the ID. Well, I've got this out. If I have an in-out or an out parameter, I can't assign a default value. I can't skip over it. I've got to provide a variable for that spot. So the classic solution here is not to tell everybody, sorry, when you use that notification, you're going to have to create this dummy variable, and you're going to have to assign PID to that, or the dummy variable to PID. That's a really bad feeling for developers using your code. They won't like you as much as they used to. So the classic solution is you provide an overloading. Everything's the same here, except I don't pass back PID. And in my package body, as I'm sure you can all figure out, here's my lovely returning clause to get the variable back into my out parameter. Here's my second overloading for add notification. No parameter for PID. I just declare a local variable, and I call the other one. And I simply provide the variable there, and I don't have to pass it back. Okay. So either you can hide parameters for backward compatibility purposes by assigning a default value for trailing in parameters. If that's not possible, you actually have a new out parameter, a new in-out parameter, then you could tell everybody, listen, the functionality has changed enough that you have to go and change all of your code so you can get these values and work with them. But the more common approach to take, and the kinder approach, is to build some additional overloading so that their existing code will work just fine, even as you add these out and in-out parameters. But the key thing is, if you've got these multiple iterations that are almost the same, I'm doing an insert. So I could have said, well, for this implementation, for this table API procedure, it does nothing but an insert. I'm just going to take this, and I'm not going to call add notification. I'm going to do this and just assign it into LID. Right? So I could have taken this approach for my second version of add notification, and I never passed back the ID. The downside of this approach is that over time, I might want to do more than just an insert. So let's go back to the TAPI conversation. So I say TAPIs are pretty good. You never write an insert in your code. You always write a procedure that does the insert. You always call the procedure. And people say, oh, that's ridiculous. You shouldn't have a procedure that just does an insert. That's not enough added value. So I disagree on a couple of elements of that. One is you can always add value by having good exception handling, which I haven't put here yet. And chances are that'll be better than you having to remember to do the exception handling yourself. But the second thing to think about, if somebody ever complains about you writing a procedure that just has a single insert, or you're asking yourself this is a kind of a placeholder. You're saying, I didn't say, for example, notice, I didn't say insert notification row. I said add a notification. This is an action in the application. And chances are over time, adding a notification will involve more than just doing the insert. So what I've created is my placeholder so that I know whenever I need to modify the behavior around an insert, I go to this one place, and I might do the insert and then add some other things after it, usually add something after it. And then this add notification, by not doing this approach, but by always making sure that I'm calling the existing source add notification, it gets all those other things added as well. So when you're doing these kind of overloadings for backward compatibility, make sure there's a single source implementation. Do not feel bad or that you're wasting your time if you write a procedure that so far just has an insert or just has an update. Chances are they will get more complex over time, and you're ready for it because you've created this place to put all that logic in one place. Everybody takes advantage of it by calling that single procedure. Okay, let's see. I think there's one more thing I'll mention, and that is that there are two ways to associate formals with actuals, and that is with name notation or positional notation. So here's a procedure, name notation demo. I've got 5 parameters: in out, in with a default, out, in with a default, trailing. And there are all sorts of different ways to call this procedure. All of these are valid ways. Here's an example of positional notation. I provide a value for each parameter, an argument value for each formal, and it's associated positionally. I can even just provide 4 of those because I have a trailing in parameter. I can't provide a default. I can't skip over this one and use the default using positional notation because there's no way to say skip over. It's positionally associated. But I can also use name notation and explicitly associate argument values with formals. And then I can change the orders. I can skip over internals with default values, all sorts of things. In general, you should always use name notation in your code. It's easier to understand, easier to maintain, less likely to break over time. Okay, it's 11:26. Why don't you stop sharing my screen? That was a lot of straight sharing. And let's pull my head back. Sorry, it's hard to figure out where to move my mouse because my laptop is below the main screen right now because the other configuration stopped working because my Logitech keyboard, which had coffee spilled on it, doesn't work. Got to get a new one. Okay, hope that was enjoyable. That was very quiet. Feel free if you've got any questions or comments or stories of your own concerning parameters. There we go. Rachel, what situations do you recommend an in-out mode parameter instead of 2 separate parameters? Well, so in-out having 2 parameters versus 1. So that probably raises the issue of parameter aliasing, which I wasn't planning on getting into. You could have 2 separate parameters, one going in and one going out, but then you're going to have 2 separate variables or the same variable. If you're going to have the same variable, in other words, if your code might look something like this. See, here's my procedure called very confusing. It has 3 parameters, an in, an in-out, an in-out, another in-out, and I'm passing the same variable to each one. Then you get into some issues with something called parameter aliasing. Honestly, no matter how many times I read the documentation about parameter aliasing, I get confused. I could run the script and show you some of what's going on, but the main thing is you should not do things like this. So I would answer, now stop sharing my screen, please. Come on, mouse, you can do it. There we go. So I would say that in general, you should have a single in-out parameter if you're passing in the same variable and you're simply changing the value in your procedure or function, though in-outs in a function are kind of weird. Then use the in-out. If you're passing in one variable as the in and the value that's being set to is a different variable, then having 2 different parameters makes perfect sense. Hamal. Use less number of parameters and modify the passed values, i.e. insert a table, a new value based on a set of conditions without having to create local variables as in parameters. RO, what is RO, Jamal? Use less number of parameters. I'm sorry, I don't understand that comment. Feel free to elaborate, but I'm not sure what that means. But could you show it again for a second, Mark? So one of the things I might be talking about here, and I didn't talk about it in my presentation, is that if you have a lot of parameters, let's go back and share my screen, please. The notifications. So what you see here is an add procedure that has a formal parameter for each column in the table, which is not uncommon for table API type codes. So a very common overloading here and a different way to pass parameters would be something like this. Oops. Only I could type row in, and I'll just say notifications % row type. So I could, as an overloading, and I think it's a really good idea, pass an entire record as opposed to individual column formal parameters. One of the advantages here being that as I add more columns to the table, when I recompile this code, it will automatically take on those new columns. That's really sweet. The downside with APIs like this, from an Apex Oracle Application Express standpoint, which is the environment I work in for the most part, and more PL SQL developers as well, is that there's no really good support for records inside Apex. There are just a whole bunch of items. And therefore, this is the kind of API that you tend to need to use with Apex, or you're going to assign all the individual items into a record and then call the record-based API, which doesn't make a lot of sense. But I'd say in general for table APIs, having row-based parameter lists is great because then you don't have this enormous list and it's easier to manage. And that may be what Jamal was talking about. Feel free to educate me if I'm wrong. Please stop sharing my screen. Okay, so I think we're out of time. Yeah, so let's see, cultural artifact. If you could share my screen again. I'm running out of my favorite books and so on, so I thought I'd show you something else. And that is one of my favorite physical artifacts. God, my mouse is crazy. Okay, that's a bicycle. This is a bicycle that I had built for me back in 1978 when I was in college. And a friend of mine had a friend who built bicycles from parts. And this bicycle has lasted since that point. I haven't been riding it continuously since then, but it's got an actual lot of original components. So this is a Reynolds 531 tube, a steel tube. I'll show you a link to it in just a moment. This is back when Raleigh was an actual UK company. It's now built in China. Notice metal gear derailleurs. Oh, metal shifts, not index shifters. This is an old school bike, and boy, did it last a long time. I'm riding it now in North Carolina, and it's built around these really cool Reynolds. My mouse, so silly. Reynolds 531 tubing. So Reynolds technology has been around for years and years doing these great bicycle frames. And it's worked out so well. I'm just so happy to be able to be riding on a bicycle that I have repurposed and supported and enhanced over the years and fixed as needed since 1978. I have bought new bicycles along the way as well, but this one has lasted all the way through. So I encourage you to do the same thing whenever possible. Reuse, repair, do not buy things new. That'll help save our planet. And finally, we're going to make a donation to the Ukraine efforts in the Red Cross. The Red Cross efforts in the Ukraine to respond to that global humanitarian crisis that has been created by Russia and Vladimir Putin. So again, I thank INSOM for supporting this as part of my Feuertip. And actually, one final thing. On the topic of plastic, hopefully you're all dedicated to reducing the amount of single-use plastic you do use. And one of the things I really hated about single-use plastic for a long time was buying these enormous jugs of laundry detergent. Really big, really thick plastic, because they had to be, they're heavy. Well, it's now possible to no longer have to buy liquid detergent in a big plastic jar. You can buy Earth Breeze, which are basically they're sheets, they're soap sheets that you just throw into the laundry. Works great. Even my wife, even women think it works great because it doesn't take much to impress me when it comes to laundry. And there are other options as well. Please look for opportunities to avoid buying big jugs of laundry detergent and so on and so forth. Please stop sharing my screen. All right, so thank you so much for joining me. A little bit less ranting, hopefully some good advice around parameters. Hopefully you enjoyed my bicycle and maybe have some bicycle stories of your own you can share with me next time. In the meantime, so it's coming on the end of July, summertime. Maybe I'm not taking a whole big vacation, but I am going to take August off for Feuertips. So the next Feuertip will be September 7th. We will have Monica back on, the motorcycle riding DBA, who's going to talk about how she organizes her PL/SQL code. So I'll be letting you know all about that as we get closer. But in the meantime, have a great, safe summer. Please, the pandemic is not over. Wear masks whenever you're indoors. Avoid being indoors to eat, et cetera, et cetera. COVID is not done with us. People are still dying in large numbers and getting sick in large numbers, and we don't know all about long COVID yet. So be safe, don't take chances, and hopefully stay cool as well. Take care, everybody. See you soon. Happy PL/SQL coding.